The first stage of cellular respiration is glycolysis. Glycolysis takes place in the cytoplasm. And what we will see is that the first ingredient, glucose, which is a 6 carbon sugar, is eventually broken down into two molecules of pyruvate, which are 3 carbon compounds. So glucose, 6 carbon, on the completion of glycolysis, 2 3 carbon pyruvates. Now, it is a little more complex, but you should know that we begin with glucose. We use 2 ATPs, but produce 4 in glycolysis, hence a net amount of ATP as 2 ATPs. You also, at some point, produce 2 NADH. These are electron carriers, and eventually 2 3 carbon pyruvate compounds. The second stage of cellular respiration is or occurs in mitochondria. So you have acetyl CoA. These transport the pyruvate into mitochondria, and this enters a pathway called the Krebs cycle. Now, in the Krebs cycle, which occurs in mitochondria, once again, carbon dioxide is used here. You also produce 2 electron carriers, NADH and FADH2. These carry electrons to the third stage, and a net ATP production of 2. This takes place in the Krebs cycle and occurs in the matrix or in the inner part of mitochondria. So eventually, your pyruvate splits into carbon dioxide. Notice that your pyruvate is changed into oxaloacetate. Carbon dioxide occurs here as well, but your net production is 2 ATPs and electron carriers, NADH and FADH2. Now, the last part, stage 3 of cellular respiration, occurs on the cristae or the membrane. So, electron transfer phosphorylation. What happens here is that electrons are brought from the electron carriers NADH and FADH2. The ATPs here, 32, are produced because the electrons go up and through and up and through the cristae or the inner membrane of mitochondria, and as they do this, they form ATPs.